Okay, here we have a question about organic compounds, which consists of only carbon, hydrogen, and oxygen. And then this compound has a relative molar mass of 86 gram per mole. And then the combustion reaction of 0.40 gram of this compound with excess oxygen produce 1.1 gram of carbon dioxide and 0.45 gram of water. So in this case, the first question is asking about the empirical formula of the compound A. Here we are going to use the mass of the product that is produced, in this case carbon dioxide and water. So from the carbon dioxide, we are going to calculate the amount of carbon. And then from the water, we then determine the amount of hydrogen. And then after we know the mass of the carbon and the hydrogen, then we're going to use these to calculate the remaining amount of oxygen in the compound. So in that case, this is the question A. So here we have 1.1 gram of carbon dioxide. So if we want to calculate the mole of CO2, so this is calculated by the mass over molar mass in this case. So this is 1.1 gram and then divided by the molar mass of carbon dioxide, which is 44 gram per mole. Okay. And then from this, we are going to calculate the mole of the carbon, which is 1-to-1 ratio. So let's say in this case, mole carbon equals to mole of CO2, right? Because it is 1-to-1 ratio in the CO2 molecules. And then if I want to know the mass of the carbon, then it means that it is like mole of the carbon multiplied by the molar mass of carbon. So in this case, I can then use this amount. So 1.1 gram, 44 gram per mole. And then the molar mass of carbon, which is 12 gram per mole. Okay, so in this case, we have an amount of 0.3 grams. That is the mass of the carbon. Now the next one here is we are going to calculate the mass of the hydrogen from the mole of water. So now we have mole of water, which is calculated mass divided by the molar mass. So in this case, we have an information 0.45 gram of water, and then divided by the molar mass of water, which is 18 gram per mole. And then if we see the formula of water, which is H2O, then we know that if we want to know the mole of the hydrogen, then it is like twice of mole of water. And then if we know the mole of the hydrogen, then we can calculate the mass of the hydrogen here, which is the mole of hydrogen multiplied by the molar mass of hydrogen. So in this case, the mole of the hydrogen is twice of the mole of water. So this is what we are going to use, and then multiplied by 1 gram per mole, which is the molar mass of the hydrogen. So in that case, we have 0.05 gram of hydrogen. Now remember that in the question we have an information that the compound A consists only of carbon, hydrogen, oxygen. So if we already know the mass of the carbon, mass of the hydrogen, then we can then calculate the mass of the oxygen as the remaining element in the compound. So in that case, the mass of the oxygen, that should be mass of compound A, and then minus mass of the carbon and minus mass of hydrogen. So in that case, the mass of the compound A is 0.43 grams. So 0.43 minus mass of the carbon, which is 0.3, and then the mass of the hydrogen, which is 0.05. So here we have 0.08 grams. So after knowing the mass of each carbon, hydrogen, and oxygen, then we are going to determine the empirical formula of this. So in this case, when we know that the compound A is consisting of carbon, hydrogen, and oxygen, so we are going to use that. So this is we want to know the mole of the carbon, and then mole of the hydrogen, and then mole of the oxygen. So we want to know the ratio. So in that case, mole of the carbon is the 0.3 gram over 12 gram per mole. Oh, sorry. And then the next one here is the mole of the hydrogen, which is 0.05 gram, 1 gram per mole. And then mole of the oxygen, which is 0.08 gram, divided by the molar mass of the oxygen, which is 16 gram per mole. So in this case, we have 0.025, 0.05, and this one here is 0.005. So if we take 0.005 is like the smallest number, so we divide all these three numbers with 0.05. So I'm writing here, we divide all with the 0.005. So here we have like 1, we have 10 over here, and we have 5 over here. So the empirical formula, then we have C5, H10, and then O1 is the empirical formula of the compound A. And then the next one, the question B, that is determining the molecular formula of the compound A. And then in the question, we have information that the molar mass is 86 gram per mole. So basically, we want to calculate what is the N value. So in this case, the empirical formula should be, let's say, N, and then multiplying with the empirical formula. And this one should be 86 gram per mole. And then we're going to check. So in this case, we have N, and then we have 5 with 12 gram per mole, and then we have 10, 1 gram per mole for the hydrogen, and then we have 1 with a 16 gram per mole for the oxygen, and then this should be the same as the 86 gram per mole. Then we find that we have 60 plus 10, which is 70, and then we have 16, so we have 86. So in this case, the N value is actually 1, because this is the same number, 86 gram per mole. So we can conclude that the N value is 1. So in that case, the molecular formula of the compound A is the same as the empirical formula. Okay, and then the third question. So here we have an information that the compound A has the following 5 possible structures, and we have to write the IUPAC name for each of this compound. So basically, um, 5 possible structure means that these 5 structures are isomers that they have the same molecular formula, but they have different structure and they have like different properties. So let's start from the first one. So what you have to look for is the functional group of each of these compounds. So for example, this one here is the CO, that is the alkanon or keton. And then this one here, this is CO, but this is like at the terminal. So we actually have H over here, hydrogen. So this is actually like COH. So this is like CO, which is alkanon or keton, and this is basically like COH, which is alkanal or aldehyde. And then this one here, this is in the middle, the carbon in the middle, so that is also the keton or alkanon. This is CO. And then the next one here, this is also in the middle, so this is here, so it's not at the terminal, so that is also the carbonyl of the keton or the alkanon. While this one here is at the terminal, so this is actually aldehyde or alkanal, so this is COH. So now we are going to like naming this compound. So for example, the first one here is the keton, and then we are going to calculate like the number of the carbon. So for example, 1, 2, 3, 4, 5. So that is like pentane. But this is the alkanon, so pentane, and then we like naming or giving the number for the carbon, in which we give the smallest number where the alkanon resides. So in that case, this is like carbon number 1, 2, 3, 4, 5. So we have pentane, the number of the C in which the alkanon is there. So that's number 2. So then we have like on over here. So pentane 2-on, or sometimes it is called 2-pentanon. That is also similar, or it's the same for the same compound. And the second one here is the alkanal. And remember that for the alkanal, the C number is always number 1. So here, number 1, 2, 3, 4, 5. So also we have 5. And then the position of the alkanal is always at the number C number 1. So we don't put number in the name of the aldehyde compound. So in that case, we just write down pentanal over here. And the third molecule here, we have keton or alkanon, in which the position is at the carbon number 3. So here, this is exactly in the middle. So in that case, this is pentane, but this is alkanon. So we just like put here on. So this is actually pentan 3-on or 3-pentanon. And then the fourth molecule over here is also alkanon, because this is in the middle, not at the terminal. So that we have to look for the backbone, main backbone of the compound, in which this is like the longest chain, in which includes the carbonyl. So this would be this one here. Okay, and then we can get or put a number in which we want to have the smallest number for the alkanon here. Okay, so in this case, we see that now we have a side group over here. So we have like a side group, which is methyl over here. And then the position is like at the number 3. So we are going to put a 3 methyl group here. Okay, so the name is like 3-methyl butane in the position of the carbonyl, this one here. So 3-methylbutane 2-on, or 3-methyl-2-butanone. And then the fifth chemical over here, this is also has a side group, so we have to determine the main backbone. So this is the main backbone, and we want to like give the carbon the smallest. It's a alkanol, so this is always number 1, 2, and then 3 and 4. So here we have a side group over here, which is the methyl group. So in this case, we are going to put the name here, which is 3-methyl. This is butanol. Okay, so we make or we give the name without space because it is this one for one chemical. Now let's take a look at the question D. Here we have a reaction. So what you have to look for is the functional group. So in this case, this is the functional group. This is ketone or alkanon, and this is having like double bond. And then you remember that the double bond has like one sigma bond, and then one p bond, right? Now this p bonding has like the smallest overlap, so that it is easier to attack. What does it mean? It means that these will be like broken down. So basically, we have like I'm going to draw this, something like this. So basically, we have like something like this. Okay, we have like O, which is open, and then we have like a free hand over here. And then because we have like hydrogen over here, so basically one hydrogen will be here and the other hydrogen will be here. Okay, so basically we have an alcohol. Now if we have to like write down the correct structure using the line structure, then it will be, so if I have to draw the structure, the result, the product, so this is basically the product. Okay, and the name, if I have to give the name, then it should be like, for just like giving the number, 1, 2, 3, 4, so 5. So this is pentane 3-ol. So this is 3-pentanol or pentane 3-ol. Now the question E, of the 5 isomers of compound A, which isomer can be oxidized to a carboxylic acid? So the carboxylic acid here, then we should look for aldehyde compound. We are using our alkanol. So in this case, aldehyde is having the group of COH. Now this COH will then change into COOH of the carboxylic acid. So for example, we have an oxidator over here, and then we have like COOH as the carboxylic group. Carboxylic acid. So in this case, from the 5 molecule, we have 2 aldehyde compounds. So the pentanol, so this one here, pentanol, and 3-methylbutanol.